Hi, welcome back to Intermediate Algebra. Today we're looking at section 4.4, Systems of Linear Inequalities. So we've graphed linear inequalities, we made lines, and they're either solid or dotted, and we shaded one side. Now we're going to do it with more than one line. It's going to be not really any harder, just a little bit more work. And so we can do this. All right, so I have the steps here, and then I'm going to do 2 or 3 examples, and yeah, then I'll send you on your way. So, number 1, graph all lines. First question, when you're graphing those lines, are they supposed to be solid or dotted? Remember, we talked about this in a previous chapter when we did the graphing with these before. Solid lines, if you have a less than or equal to or greater than or equal to sign, remember that means that the border is included. Dotted lines, if you have strictly less than or strictly greater than, the border is not part of the solution. That's step 1. Step 2. Determine which side of each line should be shaded. Okay, so this is what we did again before in that previous section. Pick a point that's not on the line. If you plug it in and it makes a true statement, shade that side. If it doesn't work, shade the other side. And then number 3, the solution is the overlap. So we're going to have at least two linear inequalities, possibly 3 or 4, and the solution is going to be where all those shaded parts overlap. And so sometimes colored pencils are helpful here. Sometimes you just have to be really careful. So anyway, let me get my first example up on the board, and we'll look at that one. All right, so my first example is the system with x is greater than or equal to 0, y is greater than or equal to 0, and x plus y is strictly greater than 5. So the first thing that I notice here is those first 2 lines have the line underneath, so those are going to be solid lines, and the last one does not, so it will be dotted. Now, I know that x equal to a number is always a vertical line. So for x equals 0, because I remember I'm trying to graph that line, it's just a vertical line right at the y-axis. There's x equals 0, and I'm not sure how well you can see that line since it's right on the y-axis, but it's there. I have a line right on the y-axis. And since I want it to be bigger than 0, well, where are the x values bigger than 0? Left or right? Well, the answer is they are bigger out to the right? If you go to 1 or 2 or 3, those are bigger than 0. So you'll notice I put some arrows here, just kind of marking that I have this line and that I should be shading out to the right of that. Okay, remember, my goal here is to find where these regions are all going to overlap. So I'm just kind of giving myself a little bit of markings there to kind of point the way as I go through this. For y is greater than or equal to 0, I do the same thing. It's another solid line. This is the line underneath. And I know that y equals 0 is a horizontal line, and so it is right on the x-axis. You can see I'm in the way. You can see out here I wrote it, that's y equals 0. Again, it's a solid line. And since I want it to be bigger than 0, I am going to be shading above. And so again, I put those little arrows here to show that I'm shading above. And so before I even get to this dotted line here that I already have on the board, you'll notice that from the first 2 lines, the region that is going to be shaded is the entire first quadrant. Now, we still have a third line that we're going to throw in here. It's already there. So what we're looking for is the overlap. So I need to be to the right of that first line. I need to be above the second line. That's going to be the whole first quadrant. Let's see what the third line does. So the third line is x plus y is greater than 5. I made a quick little t-chart to find 2 points. I plugged in 0 for x, which made y have to be 5. And then I plugged in 0 for y, which made x have to be 5. And so that got me these 2 points, 0, 5, and 5, 0. I made a line. It's dotted, although I have a confession here. When I started drawing this on the board, I made it a solid line, and I had to go back and erase it to make it dotted. So be careful. It's a really easy mistake to make, to forget that one of those lines should be dotted. All right, so there's my third line, and the only question left was, which way do I shade that one? Because it's going to make a difference. So I plugged in the ordered pair 0, 0. Right, this is a trick we learned back in a previous chapter. If I plug in 0, 0 for x and y, 0 plus 0 is 0, And 0 is definitely not bigger than 5. That's a false statement. So I know I don't want this side of that dotted line. I want that side. And so when all is said and done, what I have is I have a big portion of this first quadrant, but not the whole thing. I'm missing this little triangle down here. And so it's really important that you actually pay attention to where you're supposed to be shading, because a lot of people are going to go for that triangle. It looks like what you should be shading because it's this nice little triangular region. But it's important to note that this one was going away from the origin, so it wasn't the triangle, it was this big part out here. So there's one example. I think I'm going to do one more. So here we go. Oh, there we go. Sorry. All right, so for my last example, I have y is greater than 1/2 x minus 3 and negative x plus 2y is less than 4. All right, so here, first thing I notice again, these should both be dotted lines. So this time I have one line that's in slope-intercept form. I'm going to take advantage of that to make that graph, and then I made a table of values for the second one. So let's do that first one. Y is greater than 1/2 x minus 3. So I notice that my y-intercept is -3. My slope is 1/2. So from that point, I went up 1 and over 2 to get a second point, and that made my line. Again, I'm being careful. I'm remembering that it is a dotted line. Really easy to forget. So the only thing left for that first line, which is this one right here, is to figure out which side of it would need to be shaded. So you can see up here I plugged in 0, 0. I like the origin. It really is my favorite point to plug in. If I plug in 0 for y and for x, I get 0 is greater than -3, which is a true statement. So for that line, I shaded toward the origin. The other one, this time, since I didn't have y all by itself, I made a table of values. When I plugged in 0 for x, 4 divided by 2 gives me 2 for y. And then if I plug in 0 for y, I get negative x is 4, so dividing by -1, you get -4 is 0. So I have 2 points for that one as well. I have 0, 2, and -4, 0. Again, it's a dotted line because it's strictly less than. And then I plugged in the origin. I really like the origin. So I have -0 plus 2 times 0 is less than 4. All that whole left side is 0. 0 is less than 4, that's true. So again, it's shading toward the origin. This time, as you can see, the first line is shaded up, the second line is shaded down. And so we want that overlap. It's going to be all this region here in between these parallel lines, which should be parallel. You're a little iffy looking on my board, but they should be parallel lines. So there you go. That's graphing systems. A couple of things to just remember to be really careful with. Number one, are they solid lines or are they dotted lines? Okay, it's a really common, really easy mistake to use all solid lines because we're used to drawing lines with solid lines. Number two, make sure you're shading the right place. Take the time to test a point and make sure that you're shading in the right direction. I get a lot of people on my tests who graph these and the lines are pretty good, and then they graph completely the wrong part of the graph because they just were in a hurry, I think, sometimes to just shade what looks like it should be shaded. The most obvious example was that one that we did first there, where there was that beautiful little triangle right there along the axes, and it wasn't the region that we wanted. So please be careful. Take your time. It really is worth it. So good luck with these, and have a great day.